at your homework, you have a circuit very similar to this. It's not identical, but it's very similar. So when you get to your homework, you'll have an idea as to what's going on. So what is the counting sequence of this circuit? So this means how do the numbers go? How do they rotate? Let's assume that we start with Q0, Q1, and Q2 equal to 0. So they all start at 0. Okay, so first of all, is this a positive edge triggered flip-flop or a negative edge triggered flip-flop? Or is it a latch?
I think it's positive.
It is. It's a positive edge triggered flip-flop. What that means is anytime the clock goes from low to high, then that is when the flip-flop changes its value, if it's going to change. And that's the only time it's going to, is when the clock goes from 0 to 1. So I'm actually going to put well, I'm not. So notice on this one that it's actually the clock that is going into the clock input. But you don't have to have a clock going into the clock input. It can be some other signal. And so if it's another signal, what you're saying is whenever that signal goes from 0 to 1, that is when that particular flip-flop will change values, if it's going to change values. Now, what is my input into, I'll call this one, this is 0, 1, and 2. What's my input into the first T flip-flop? It's 1, and what does that mean for a T flip-flop?
It means that it will change until, I don't know.
Yeah, so for a T flip-flop, let's remind ourselves what a T flip-flop does. So if I have so Q is the output that I had before. And if T is 0, there's no change. My new output will be the same as my old output. If T is 1, my output toggles. It'll be the complement of what it was before. So if T is 1 and Q is 0, my output becomes 1. If Q is 1, then my output becomes 0. So when we started, we said these were all 0. All of these were 0. Okay, so for when we get to the first time that the clock goes from low to high, the input into the first flip-flop is 1. So what's the output going to become? 1. But what's the input into the second flip-flop, into Q1 here? It was 0 because Q0 is the input into Q1. And what happens if the T is 0? No change. What's my input into flip-flop 2?
It's 0.
It's also 0. So what's going to happen to its output?
It's not going to change.
It's also not going to change. Okay, so now this became 1, so I'll change it.
So whenever we have, do we have the original value of Q 0?
I said assume they're all 0.
Oh, okay.
This said what is the counting sequence, and counting sequence, given that, you know that it's going to repeat, so it doesn't matter where we start with, we just keep going until we get to this where we started from.
Okay.
Or you can have different counting sequences depending on the starting value, and if that's the case, you'll be given the starting value. Okay, so now the next time we get to a positive clock edge, what's Q0 going to become?
Does it go down to 0?
It'll go to 0 because its input is always 1. So Q0 is always going to toggle. Its input is always 1, and the thing coming into its clock is the clock. And so every time the clock hits a high, its input is 1, and that tells it to toggle. So we know that Q0 is always going to look like 0, 1, 0, 1, 0, 1, 0, 1. It's going to toggle like that. Okay, now though, if I look at flip-flop 1 over here, its input is what Q0 was last time, which is 1. So its input is 1. So what does Q1 become? 1. Now what about Q2?
Changes. No, it doesn't change.
It doesn't change because its input is still 0.
Oh, that's from what Q1 was previously.
That's right. Its input is what
So it
Q1
stays
was
the-
before. So it stays the same. All right, so now I'll reset what all of these are. Q0 is now 0, and Q1 is now 1, Q2 is still 0. Well, we know every time Q0 toggles. So we know what Q0 is going to do. It's going to become 1. What about Q1?
0.
Are you sure?
Wait, slow down. Slow down more. I'm trying.
Do I need to slow down, or did you answer quickly?
No, he
I
answered
answered
quickly.
quickly.
Oh, okay, you're telling him, okay,
I'm telling
okay.
him
It's
to
like,
slow down. I'm sorry. I
okay.
was talking to you.
Okay, no, that's okay. I don't mind being told to slow down. That's fine. I was just wondering if I was actually the one going fast, or if y'all were like answering fast. So what we have to pay attention to is its input, and its input is the value of Q0 from the time before. And the time before Q0 was 0. And what does a T flip-flop do when its input is 0?
It doesn't change.
No, it doesn't change. The input for Q2 is Q1 from the time before, which is 1. What does a T flip-flop do when its input is 1? It toggles. So I'll get a 1.
So, okay, so it's confusing me a little bit. We have, in this instance, Q0 originally being 0, and Q1 originally being 1, Q2 originally being 0.
No, they were all originally 0.
I meant like
Oh, here.
the sequence
Yeah.
before we.
So
Does Q0 go into T, or like does that Q go into T and then that's what like is toggling it or not toggling it?
yeah, so the Q0 is the input into the T as it's
Okay.
drawn here.
Okay.
And so whatever is the input into the T, it doesn't really matter where it's coming from. You look at what its value is, and if it's 0, it stays the same, and if it's 1, it changes. And so you look at, well, what is my input into this T? It's Q0. Well, which Q0? Well, it's the Q0 from the clock cycle before. Okay, so if you get this, just close your eyes for and take a little nap for a second. If you're all good, and hold on, we'll be back in a second. Okay, so let's review. So I'm starting with 0, 0, 0. So that means that I have a 0 here, a 0 here, and a 0 here. My input into flip-flop 0 is 1. That means it's always 1 because it's the number 1, and the clock is regular, nothing weird there. So a 1 input means you're going to toggle. So I know this one is going to toggle every time. I know that's going to happen. On this first step, my input for each of these is 0, and a T flip-flop with an input of 0 doesn't change. So Q1 and Q2 are not going to change.
Right.
And then once I have that, I need to reset, and I need to see, well, what are they now? Well, Q0 is 1, Q1 is 0, Q2 is 0. So now I don't have to worry about Q0, I know what it does. Q1 now has an input of 1, so it toggles. Q2 still has an input of 0, so it stays the same. Then I reset. Q0 is 0, Q1 is 1, Q2 is 0. So now you tell me what's the next row going to be?
So Q0 is 1, obviously.
Mhm.
And Q1 is going to toggle, so it's 0.
Why is Q1 going to toggle?
Oh,
because-
no.
Wait. Q0, never mind. Q0 is not going to toggle, it's going to stay the same.
You mean Q1 is not going to toggle,
Yeah. It's not going to toggle because the T is getting an input of 0.
right?
Then Q2 will toggle, so it will change to 1.
Okay. What about now?
Now it will be.
Oh, well, let me reset it. So now they're all 1.
So it's going to be 0, 0.
It'll be 0, 0, 0.
And now I have my counting sequence because now I'm back to where I started. So my counting sequence is 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1. And if I wanted to put those as binary numbers, that would be 0, 4, 2, 7, 0, 4, 2, 7, 0, 4, 2, 7.
So in this instance, you would have to always check the sequence before to check the input going into the next.
Yeah. Now notice other things didn't show up here, so we might have gotten something very different if we had started with 1, 0, 1. And as a matter of fact, I believe your homework has something a little tricky on it that's different. So let's take a look at what this does.
I don't know why I was having such a hard time comprehending that, but I got it now.
Well, yeah, but I'm about to make things harder.
Oh,
Yeah.
So, by the way, James wanted me to tell you that he had to run. So.
Okay.
Yeah, he had to run, take someone to work. So but he said thank you.
All right. I appreciate that. Okay, I just made things a whole lot harder. But you do have to know how to do this, and this does show up both on homework and the test, and it is on your homework. Okay,
Oh, what?
what?
That
Yeah, y'all weren't paying attention. It's like, I'm trying to tell you it's harder, it's like no one's paying attention. And then I'm telling you this shows up on tests, and still no one's paying attention. All right,
I'm sorry.
that's all right. I'm used to it. All right, what's super weird about this
So the clock
is not the clock.
It's not the clock from Q0 and Q1 to Q2. They're connected through Q0 and also the output of Q1.
Yeah. So I got something really weird. For my first one, it's normal. But for the others, the clock is not the clock. That's why I was telling y'all, but you were all tuning me out, even though I was trying to tell you it was important early on about positive edge triggered and negative edge triggered. No, this is y'all were tuning me out before. So not just the last time y'all were. So when does a flip-flop change? When the clock, if it's positive edge triggered, when the clock goes from 0 to 1. So you have to pay attention to what the clock is on each of these. So let's draw this. So I've got Q0, Q1, and Q2. Now, and let's just say they all start at 0. So I just make that up. Q0, we like Q0, right? What can we already say what Q0 is going to do?
It's gonna go 1, 0, 1,
Because
0, 1,
it's
0.
always set to 1.
Okay, so Q0 is good. All right. So when we started, we said these were all 0. If this is 0, what is this right here? 1. So at the next clock cycle, is the clock for Q1 going from 0 to 1? No, it's 1. And it's not going to 1. It's going to 0. So it's not going to change.
So if the clock doesn't activate, then nothing happens.
Then nothing happens.
Okay.
And here, this 0 is not changing. It's just 0. So it's not going from 0 to 1. It's just 0. So it's not changing. Okay, so now at our next clock cycle, let's see what happened. This is 1. This is 0.
Well, this one, the clock is at 0, so Q1, nothing happened.
Yeah, the clock went from 1 to 0, so nothing happened. Did the clock do anything here?
No.
No, so nothing happened. Okay, so now let's go to the next change. This is going to be 0, and this is going to be 1. So the clock went from 0 to 1.
So it does.
It would, but what's its
still
input?
still
0.
It's just gonna be 0, 0. Yeah.
Is it ever going to change? I don't know. Let's keep going.
We should have realized this before, because the original was 0, 0, 0, and we got to 0, 0, 0 in the last step. That was a full cycle.
Ah. Yeah.
Wait, I
You're
have
right.
a question for like so Q1's input for the second sequence 1, 0, 0.
Mm-hmm.
Beforehand it was 0, right? So
You mean before we ever started?
Yeah, before we ever started, the sequence was 0, 0, 0. Why doesn't the clock flip from 0 to 1?
It does on the next cycle? You mean why didn't it? Why did I not say that it had flipped on that time?
Yeah.
Because I'm saying that was the starting time. That it wasn't coming from some before time.
Okay.
So it has to be that the clock has to have gone from a low to a high on that turn, or like on the previous turn.
Oh, okay.
Yeah. But I do see what you're saying, and let me think about it for a minute. And I'm just gonna say no, because I'm saying that's where we started.
Okay.
Yeah. But if I get something different on this next step, then I'll say it does matter. So hold on, let me think for a second. So this one would be, where are we now? Whenever this goes from 0 to 1, the input up here is going to be 0. And that means there's never going to be a change.
Okay.
Yeah.
Okay.
Okay. So let's do one where there would be a change, just so we can see what it's like. But I think that's your homework. Can someone pull up the homework? Well, I will.
By homework, you mean the free lab stuff, right?
No, your actual homework.
We have
Homework.
actual.
I did not know that.
Yeah, it's on Moodle.
That's the wrong homework. That's the wrong class.
It's due on Thursday.
Okay.
Don't be stressed. You'll be fine.
Yeah, it's due like in 30 minutes.
Right now.
Homework.
Yeah, really missing homework.
Yeah, you know those quizzes that Ramon gives you for circuits? It's basically similar to those.
I forgot about the.
Oh, well, we have a quiz today.
Yeah.
It's due like tonight.
Yeah. I forgot.
I would know.
Your homework is not always easy. So don't get the idea that it's always gonna be something you can do quickly. Okay.
They're reminded that there's homework in different classes.
Okay, so this is similar, and it is a Q bar, but it does have, let's see.
Notice the break for something else. At 4, when he was into the order, he was asking for alcohol.
My battery's about to die, so I'm gonna have to, let's just take a quick look at this. Okay, so what's Q0 gonna do? Yeah, so Q0, let's give it a different starting. Let's say we're starting at 1, 0, 1. So I'm starting at 1 and Q1 and Q2. So 1, 0, 1. And so, so I'm starting at 1, 0, 1. We know Q0 is going to flip 1, 0, 1, 0, 1, 0. Okay, so Q1, when we get to this clock cycle, let's see, when this 1 changes to the 0, this will change to the 1, which would make this active, except now that's a 0 again. So I guess that's always going to happen. So I think I drew another circuit that doesn't ever change. So let's just quickly look at your homework and see, well, why does it change? Without answering it, why do we have a change on this one? So let's look at the top one. Why is that one not just going to be nothing? If it goes from 0, 0, consider the count when it changes from 0, 0, 1 to 0, 1, 0.
Why does it changing?
So what is different about the setup from this problem from the way I set mine, the poor way I set mine up?
The clock is always going to be even to nod from the other.
So that is part of it, but that didn't, yeah.
The key difference is that you have a 1 always plugged into the T
Oh,
flip
it's
flop.
No, yes, so I've got a 1 always plugged into the T. That's the key difference. And why does that help?
Because it allows the values to progress, because whenever the 1 switch, like whenever the flip flop was triggered,
Because Q0, Q1, and Q2 are inputs into
Right.
T this time.
It's almost like it's changing the role of the T input in the clock. And so now I have to stop because my battery's about to die and it's 5 o'clock, so.